Today we're going to continue our discussion on sequences and series, particularly as they apply to what we call arithmetic sequences and partial sums. So first we're going to have to talk about what an arithmetic sequence is. So an arithmetic sequence is a sequence where the difference between consecutive terms is the same. So for example, for this arithmetic sequence here, A1, A2, A3, A4, A5, if you were to take consecutive terms, so one term right after the next, so A1, A2, if you were to subtract those, you would get the same thing as if you were going to subtract A3 minus A2, same as if you subtracted A4 minus A3 or A5 minus A4, and so on. So when you subtract one of these terms minus the term before it, we get what we call the common difference, and we represent that with the letter D. Okay, so D is the common difference of the arithmetic sequence. All right, so if you take a look at example 1, it says determine the common difference in the following arithmetic sequences and find the following three terms. So we have 7, 11, and 15. So it looks like we are adding 4 to get to the next term. So in this particular case, we would say D equals 4. And then it says find the following three terms. So we just have to add 4 to 15 to get 19, continue to add 4 to get 23, and then add 4 again to get 27. So 19, 23, and 27 are the following three terms. All right, the next example, we have 2, -3, -8. Okay. So remember, we're going to try to think of the common difference as the number that you add in order to get to the next term. So try not to think about it as, well, we're subtracting. Think of it as adding a negative if you need to. So in this case, to get from 2 to -3, we have to add -5. From -3 to -8, we are adding -5 as well. So D is going to be -5. Okay, this at least prevents us from having to give an added thing and say, oh, we're adding 4 or we're subtracting 5, right? By saying that D is positive or negative, that essentially will tell us if we have to add or subtract that number in order to get to the next term. Okay, so -8 plus -5 is -13. Add -5 to -13 to get -18. And add -5 to -18 to get -23. So we have -13, -18, and -23 as the following three terms. Okay, so with arithmetic sequences, it's helpful for us to be able to come up with a rule that allows us to figure out the nth term of any of these sequences as long as we have some information. So for example, in this last example, say I wanted to figure out what the 20th term is. I don't want to have to do that work again and again and again to get there and keep track of how many times I've done it, but there is a way involving knowing which number term we're looking for, what the first term is, and what the common difference D is, that will allow us to figure out what the 20th term is without having to subtract 5 or add -5 each time. So here's the rule. The nth term of an arithmetic sequence, so a sub n, is equal to a sub 1, so the first term, plus n minus 1 in parentheses times d. Make sure you put that parentheses in there. That way you'll remember that you're doing n minus 1, figure out what that is first before you multiply by d. So just as a reminder, a sub 1 is the first term of the sequence, d is the common difference. So another way to look at this, if it's helpful, is a sub 1 is the first term. And in order to get to whatever number nth term is, we're going to need to add d some number of times. Well, how many times do you add d? You add d n minus 1 times. So that's really all you're doing here. So to get the 20th term, we have to add d 19 times to the first term, a1. That's really all this formula is actually saying. Okay, find a formula for the nth term of the arithmetic sequence below and use the formula to find the 20th term in the sequence. Okay, so to get the formula, we need A1, the first term, and we need the common difference D. Okay, that'll give us the formula. So we can easily see here the first term is 2, and in order to get to each next consecutive term, we are adding 3. So D, the common difference, is 3. Now we can go ahead and plug those numbers in. So we have A sub n is equal to 2 plus n minus 1 times 3. And again, that parentheses is in there so that you can remember to distribute. So 2 plus 3n minus 3. And if we were to simplify that down, that would be just 3n minus 1. So now we can actually find any nth term pretty easily without needing to go through the trouble of adding D a certain number of times. So in this particular example, it asks you to use the formula to find the 20th term in the sequence. So A20 is equal to 3 times 20 minus 1. So 60 minus 1, which is 59. And you can see how much easier that makes it rather than trying to add 3 until you get to the 20th term. All right, let's look at an example that's slightly different. In this one, it says the 4th term of an arithmetic sequence is 20, and the 13th term is 65. Write a formula for the nth term in the sequence. So you'll notice in this one, you're actually not given what the first term is. You're not given what the common difference D is. And you're not given two terms that are next to each other. Okay, so let's see if we can visualize what we have here. So here's the 4th term, we're given as 20. And then here's the 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th term, which we're given as 65. Now what do we need in order to figure this out? Well, A sub n is equal to A sub 1 plus n minus 1 times D. Well, we need A sub 1. Okay, well then let's draw those in. So 1, 2, and 3. Okay. Now from 20 all the way to 65, how far apart are they? They're a difference of 45. Well, how many times did we add something in order to get to the 13th term? Well, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we added something 9 times, the same number 9 times, in order to add 45 to 20. Well, how much have we added then in each case? We must have added 5 9 times to get 45, right? In the same way, we can work backwards now and say, well, if we're adding 5 to get to the next term, we can subtract off 5 in order to get the term before it, right? So we can do that 3 times. So 20 minus 5 is 15, minus 5 is 10, minus 5 is 5. Okay, so now we have the first term is 5. The difference D is 5. So now we can plug those numbers in. So 5 plus n minus 1 in parentheses times 5. So that's 5 plus 5n minus 5. 5 and the minus 5 cancel. You're left with 5 times n. And you can verify this and see whether or not this works for the terms that were given to you. So the 4th term is 20. Okay, so a sub 4 is equal to 5 times 4, which is 20. Great. 13th term is 65. 5 times 13, that's equal to 65. Great. So it looks like this is, in fact, our formula for this example. All right, so that's dealing with the arithmetic sequence. But now let's talk about when we want to sum up our sequence. So the sum of a finite arithmetic sequence that has n number of terms is given by this formula. So the capital letter S sub n means the sum of the first n terms equals n over 2, in parentheses a sub 1 plus a sub n. All right. So what's nice about this formula is that it shortens the amount of time it will take to find the sum of an arithmetic sequence. So last time we looked at some sequences. Some of them may have been arithmetic, but not all of them. But we had to find each term, and then after you find each term, then you can add them all together. What's nice about this formula is that it actually allows you to find the sum of the first 50 terms without needing to find all 50 terms before adding them all together. You just need what? You just need that you are summing the first 50 terms. You need the first term, and you need the 50th term. You don't need to find the 20th term, the 21st, 22, like you don't need to find all of those terms in order to get your sum. So let's take a look at an example of how this works. So here in example 4, it says, find the sum of the first 30 terms in the arithmetic sequence 1, 3, 5, 7. Okay, so we're trying to find the sum of the first 30 terms. So let's just write down the formula. Okay, so we know that n is going to equal 30. We know the first term, it's given to us, it's 1. So the only thing we need to know is what the 30th term is. So this is where using the first formula that we wrote down today is going to come in handy. Okay, so to find the 30th term, we need the first term. We need to know what the common difference, d, is. In this case, the first term is 1. And then our difference, d, is 2. So this gives us the formula 1 plus 2n minus 2, which is 2n minus 1. So now we can use that formula to find the 30th term. So 2 times 30 minus 1, which is equal to 59. Okay, so that's the 30th term. This example is asking us for the sum of the first 30 terms. So we're going to use that formula so as to avoid having to find the first, second, third, fourth, all the way up to the 30th term and then add them together. So here's the formula. So S30, the sum of the first 30 terms, is equal to 30 over 2. And then in parentheses, the first term is 1, and the 30th term we just found is 59. So this ends up being 15 times 60, and 15 times 60 is equal to 900. So the sum of the first 30 terms in the sequence is 900. Okay, this next segment is really just a fun fact or story, but it's believed that when this mathematician named Gauss was 10, his teacher asked him to add all the integers from 1 to 100, thinking it was a tedious task. Maybe it was because he thought it would be a good punishment for talking in class or something. But he was asked to sum up all the integers from 1 to 100. And it's believed, or it's said, that Gauss was able to give the correct answer after only a few moments. So rather than actually add all of those numbers together, this is what he did. He lined up all the numbers that he was supposed to add up, 1 all the way to 100. Let's say he didn't write them all out. And then he lined them all up again, but backwards. So now if you take a look at this, if you look at how these numbers are lined up, you have the 1 with 100, the 2 with 99, 3 with 98, and so on. Now if you were to add each of these pairings, they all equal to what? 101. Okay, so if we were to add them all together, that's equal to 101. Well, how many 101s are there? Well, how many terms are there going across? It should be 100, right? There are 100 pairs of numbers as you go across. So, what is that sum? 100 plus 100, 100 plus 101 plus 101 plus 101, and so on. You do that 100 times. Well, you just multiply that by 100. But what's wrong with that? That's not the value of all integers from 1 to 100. That's the value of the sum of 1 to 100 twice. So if we divide this by 2, that will give us the answer. So that's equal to 5,050. Now if you take a look at what we have here, it is legend. We don't know how true this story is, but it is a way for us to look at that formula that we just used and see that really all we've done is we've summed up the first 100 terms, so n is 100, and then we divide that by 2, and then we multiply it by what? The first term plus the 100th term. The first term is 1, the 100th term is 100, so 101. So really you can see how this is a way to show that the formula works. It's a pretty neat way, so we don't really know how true this story is again, but it is a way to be able to show why that formula that we just wrote down and are using, why that formula works. All right, one last example. An auditorium has 20 rows of seats. There are 20 seats in the first row, 21 seats in the second row, 22 seats in the third row, and so on. How many seats are there in all 20 rows? Okay, so again, a problem like this, you could go about it and say, okay, I'm just going to add 20 plus 21 plus 22 plus 23 all the way until I've accounted for 20 rows. That's going to take a bit of time. It's going to be tedious. If you don't have a calculator, that's going to be a lot of mental math to have to do. So let's instead use that formula and find the sum of the first 20 rows of seats. Okay, so look at what we have here. We're finding the sum of 20 numbers, because there are 20 rows. So we know n is 20. We know the first term. The first term is the number of seats in the first row, which is 20. But we don't know how many seats there are in the 20th row. Okay, so let's, again, use the first formula we learned today and use that to find the 20th row, how many seats there are. All right, so the first term is 20. The difference d is 1. We add 1 each time. And so this ends up being, what, 20 plus n minus 1. So that's n plus 19. And so to find how many seats there are in the 20th row, we just find 20 plus 19, which is equal to 39. So now we know the first row has 20 seats. The 20th row has 39 seats. We're trying to find the sum of the first 20 rows. So that's 20 over 2. And then in parentheses, 20 plus 39. So we end up with 10 times 59, which is equal to 590. So you can see how this formula can make finding the sum of a number of terms in a sequence a lot easier, a lot less tedious, especially if you don't have a calculator, if you need to do some sort of mental math, instead of having to add, having to do 20 divided by 2, 20 plus 39 and multiplying those two, that's actually much easier.